Most fighters carry between 6 and 8 air-to-air missiles. The F-15EX has been demonstrated carrying more than 20. That number is not a typo. It is not a loading chart exercise nobody uses. It is the publicly demonstrated maximum of the newest American air superiority fighter, the only current production fighter to have placed more than 20 air-to-air missiles on a single aircraft. The question isn't why the Air Force built it. The question is how you actually make 22 missiles work in combat. Modern air combat doctrine is built around the assumption that missiles will be fired in salvos. One missile at one target is not how Burr engagements work against a maneuvering, jamming, countermeasure-equipped adversary. You fire multiple shots to raise kill probability. You fire at multiple targets simultaneously to prevent mutual support. You account for missile kinematic limits, countermeasures, and electronic disruption, reducing the probability of a hit. In a large force, high-intensity conflict, the Taiwan scenario, the Baltic corridor, magazine depth becomes a hard operational constraint. A fighter that expends its missiles in the opening minutes of an engagement must either return to base or fight without weapons. The F-15EX changes that calculus. Understanding how it does requires understanding both the airframe and the weapons architecture built around it. Why the F-15 can carry what the F-22 cannot. Start with the fundamental trade-off. The F-22 is a stealth aircraft. Its weapons are carried internally, inside closed bays, that preserve the smooth outer mold line required for low radar cross-section. Internal carriage means finite volume. The F-22 typically carries 6 AIM 120 AMRAAMs in the main weapons bay, and 2 AIM 9Xs in the side bays. Adding more requires opening external pylons, which immediately degrades RCs and eliminates the stealth advantage. The F-15EX carries no such constraint. It is not a stealth aircraft. It was never designed to penetrate defended airspace undetected. It is designed to survive through electronic warfare, speed, maneuverability, and the operational reality that in a high-end conflict, not every mission profile requires stealth penetration. Some missions require presence, persistence, and overwhelming firepower at range. External pylons on the F-15EX are not a compromise. They are the design. The Eagle carries weapons across multiple wing, fuselage, and conformal tank stations, a configuration refined over 50 years of operational use. The SEFT, amber racks, and the missile count. The specific capability that enables the maximum missile load is a combination of two systems working together. The conformal fuel tank system incorporates additional weapon stations along the fuselage, mounting flush against the airframe to reduce drag while adding both fuel capacity and weapons carriage. But the bulk of the additional missiles come from amber, advanced medium-range air-to-air missile racks mounted on the outer wing stations. Earlier F-15 variants could not safely carry large multi-missile racks on the outer wing stations because of structural and flight control limits at high speed. The F-15EX's digital fly-by-wire flight control system, combined with structural improvements and updated flight control laws, removed those limits. The amber racks became viable, opening the outer wing stations to multiple missiles each. That is where the missile count goes from competitive to unmatched. The full demonstrated configuration combines CF stations, amber rack wing stations, and centerline carriage, a mix of AIM 120 AMRAAMs and AIM 9Xs across every available position simultaneously. No other production fighter achieves this. The Su-35 carries up to 12 in a maximum external configuration. The F-35A carries 4 internally and accepts additional missiles externally at the cost of its stealth. The Eurofighter Typhoon carries up to 10. The F-15EX's demonstrated maximum exceeds the missile capacity of any other Western fighter. Here is the tactical implication stated plainly. In a scenario where both sides are firing salvos, the side that runs out of missiles first loses. Magazine depth is not a comfort margin. It is an operational variable that determines how many engagements a single airframe can sustain before it becomes a liability. The APG-82 radar and multi-target engagement, carrying 20-plus missiles, is useless if the aircraft cannot manage that many engagements simultaneously. The F-15EX carries the APG-82, a large aperture ASA radar derived from the APG-63V3 and incorporating ASA technology used across modern U.S. fighter radar programs. The APC-82 can track multiple targets simultaneously and support concurrent AIM 120 engagements across that track file. It operates in low probability of intercept modes, though its design priority is resolution and track capacity, rather than the deep LPI optimization of the APC-77. Against a large force ingress, the F-15EX can sort, prioritize, and engage multiple threats across a wide front, a function that requires both radar capability and processing bandwidth, both of which the APC-82 provides. The radar's large aperture also improves performance against small cross-section targets, cruise missiles, smaller UAS platforms, an increasingly significant threat in any high-end conflict. EPOS, the electronic warfare layer. The Eagle Passive Active Warning Survivability System is the F-15EX's integrated electronic warfare suite. It replaces the older TWOS system and incorporates radar warning, geolocation of threat emitters, and active jamming into a single architecture, degrading radar tracking and missile guidance through electronic attack. EPOS matters for the missile-heavy loadout for a specific reason. An F-15EX, carrying a full external load, has an RCs significantly larger than fifth-generation aircraft. It cannot hide. Its survivability in a contested environment depends on electronic warfare, detecting threats before they achieve firing solutions, and denying the track quality required to employ weapons effectively. EPOS is the system that makes the F-15EX's non-stealthy profile operationally viable in environments where stealth aircraft are operating alongside it. Data link integration. The F-15EX is fully Link 16 compatible and is being upgraded for advanced tactical data link integration under ongoing modernization programs. In a mixed force, F-22s and F-35s as the stealth penetrators, F-15EXs as the long-range missile magazine, targeting information passes from low observable aircraft to non-stealth shooters through data link networks and gateway nodes. The F-22 finds the target. The F-15EX provides shots the F-22 cannot carry. This concept is central to how the Air Force plans to use the F-15EX. It is not a replacement for stealth. It is a complement to it. Taiwan Strait. A large PLA Air Force package is pushing east. J-20s forward as sensors. J-16s behind them as missile trucks with electronic warfare support. Strike aircraft further back. The package is using coordinated electronic warfare and disciplined emissions control. 40-plus aircraft. 2 F-22s are forward, passive, building the track picture from all 94 detections and off-board E7 data. They are not transmitting. They identify the lead J-20 elements as the primary threat and take the first shots. AIM 120s from the internal bays, fired before the opposing aircraft can achieve a firing quality track. Behind them, a foreship of F-15EXs is holding at distance. Data link picture current. APC-82 radars in standby. Targeting information is passing forward through gateway nodes from the F-22 track file in real time. As the J-20 escorts engage the incoming AIM 120s, and the package begins to break formation, the F-15EX flight lead activates the APC-82. The track picture is already built. He is not searching. He is sorting. The radar confirms 4 firm tracks on J-16s, now separated from the main package. 8 AIM 120s off the rails. Mid-course updates running. The J-16 pilots are reactive, already in a defensive posture against the F-22 shots. The second salvo arrives before they can fully reset. The F-15EX element still has missiles remaining. The engagement is not over. The package is still coming. The F-22s, now Winchester on Ver weapons, are already turning cold. The F-15EXs hold the line. That sequential, layered employment, stealth penetrators as the tip, high magazine platforms as the sustained firepower, is the doctrine the F-15EX was bought to execute. The F-15EX's load capacity comes with direct trade-offs. The aircraft's RCs, in a full external loadout, is significantly larger than fifth-generation aircraft. Against a peer adversary operating long-range surface-to-air missiles, the HQ-9, the S-400, and F-15EX cannot operate in the same threat envelope as an F-22 without accepting substantially higher risk. EPOS improves survivability. It does not eliminate the signature disadvantage. The F-15EX depends on stealth aircraft clearing or suppressing the threat environment before it can operate effectively. The maximum missile configuration adds weight that affects performance, range, acceleration, and maneuverability all degrade under a full load. In practice, mission-specific loadouts will trade some missile capacity for fuel or other considerations. The demonstrated maximum is a ceiling, not a default combat load. The APC-82, while highly capable, does not incorporate the deep LPI optimization of the APC-77. In an environment with sophisticated ELINT coverage, the F-15EX's radar emissions are more detectable than those of a fifth-generation aircraft in LPI mode. Radar activation is a tactical decision with survivability implications, and the F-15EX's multi-target engagement capacity, while substantial, is bounded by processing and data link bandwidth. The exact limits of simultaneous engagement capacity are not publicly confirmed. The F-15EX acquisition, the Air Force is under contract for over 100 aircraft, reflects a specific lesson from wargaming large force, high-intensity Pacific scenarios. In those simulations, stealth aircraft run out of missiles. The F-22 fleet is small. The F-35's internal capacity is limited. In a sustained multi-wave engagement against a numerically superior adversary, the U.S. runs a magazine deficit before the adversary runs a platform deficit. The F-15EX addresses that deficit directly. It is the most cost-efficient way, per missile delivered to the fight, to increase total shots available to a commander in a single engagement cycle, at roughly $90 million per aircraft, compared to the much higher acquisition and life cycle cost of fifth-generation aircraft. The cost per hardpoint is substantially lower. China has noted this logic. PLA Air Force Large Force Employment Doctrine attempts to overwhelm U.S. magazine depth through volume, accepting attrition on the Chinese side, in exchange for forcing U.S. aircraft to expend weapons early and return to base. Against an all-stealth U.S. force with 8 missiles per aircraft, that attrition strategy has real merit. Against a mixed force where an F-15EX can sustain the engagement through multiple cycles, the calculus changes. The broader implication is architectural. The U.S. Air Force is moving toward a force structure that pairs low observable penetrators with high-capacity shooters, each doing what the other cannot: stealth to find and open the engagement, magazine depth to sustain and close it. Neither platform alone is sufficient. Together they address the two problems that define large force air combat: access and persistence. NGAD and the forthcoming collaborative combat aircraft programs will extend this logic further, potentially pairing sixth-generation manned aircraft with unmanned wingmen carrying additional missiles as external magazines. The F-15EX is not the endpoint of that concept. It is the proof of concept, flying today, at scale, with missiles on every hardpoint. The F-15EX doesn't win by being invisible. It wins by still having weapons when every other aircraft on the net has gone Winchester. And in a war decided by who runs out first, that is not a secondary capability. That is the mission.